Good morning, good afternoon, and good evening, everyone, wherever in the world you may be joining us from today. My name is Francesco Del Carpio, and I am the CFL York Operations Coordinator. I would like to officially open the 8th session of our VR/XR Training and Education Knowledge and Experience Sharing Speaker Series, presented in collaboration with the DexR Lab at York University with a land acknowledgement. We acknowledge and recognize that many Indigenous nations have long-standing relationships with the territory upon which our campuses are located that precede the establishment of York University. The area is known as Tkaronto and has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. The territory is subject to the Dish with One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region. As this is an online event, our participants may be joining from various locations, so I strongly encourage you to learn about the traditional land upon which you are located. With this, I welcome our moderator, our speaker, and our participants from around the world. Welcome to our webinar. Without further ado, it is my great pleasure to introduce our moderator, Dr. Ahmad Mohammadi. Dr. Ahmad Mohammadi is a postdoctoral fellow in the Department of Civil Engineering at York University in Toronto, Ontario, where he received his PhD in transportation engineering. His research focuses on applications of virtual reality in transportation safety, traffic conflict analysis, and traffic microsimulation modeling. His research contributes to improving transportation safety and efficiency. Ahmad is also the coordinator of Disaster and Emergency Extended Virtual Reality, or DexR, Laboratory at York University. Dr. Ahmad, thank you very much for moderating today. The floor is yours.
Hello, everyone. Thank you very much, Francesco. Welcome back, everyone, to another virtual reality-based training education speaker series. Thank you for joining us today. My name is Ahmed, and I will moderate today's sessions. I manage the questions, keep time, and ensure that everyone has a chance to participate. For today, we have a great topic, and the topic is augmented and virtual reality sandboxes as digital twins of learning spaces. We have a fantastic expert in this area who shares her experiences with us. The main presentation would be around 30 minutes, and we will hold a question and answer session afterward. Please feel free to write your questions in the chat so that we can go through those questions after the presentation. Now it's time to introduce our speaker. Our speaker today is Dr. Mojgan Jadidi, who is an associate professor of geomatics engineering at Lawson School of Engineering, York University. She is a founder of Geospatial Visual Analytics lab. Her research interests include geospatial visual analytics, building information modeling, and 3D GIS data integrations, and also virtual and augmented reality application development for better and informed decision-making in the context of smart building, infrastructure, and cities. She is currently the Associate Director of Esri Center of Excellence at York University. She's also serving as a Secretary of International Society for Photogrammetry and Remote Sensing Commission Working Group 9, enabled urban and regional digital twins. She's also IEEE member, Women in Engineering and Geoscience Group since 2014. Now let's pass the discussion over the speaker, Dr. Mojgan Jadidi. Here we are.
Hello, everyone. Thank you, Ahmed, for that true introduction. So I'm going to start sharing my screen. You can let me know if you can see my screen. Yes, you all have control? Okay. All right. That's quite sad. We cannot see our audience, but I have this feeling we are in the virtual world. So let's start the conversation about how we are using this technology in our classroom and toward the digital twin of our learning space by this story. Imagine you have a classroom where history can come to alive, where the science experiment are as vivid as real life, and where a student, they can travel to far off places without even leaving their seats, which we are doing now. This is not a science fiction. This is all about power of augmented and virtual reality in education. Today, I want to embark you in the journey with me to show you some of the activity and application we develop, which is helping for the new dimension of the learning, where technology is just isn't just a tool, but it's an immersive experience that can transform how we can teach, how we can learn as a student. So welcome to the future of the education, where the classroom is just limited by our own imagination. This is really the motivation for me. As Ahmed mentioned, I am an associate professor, but just a correction, not in geomatic engineering anymore, in civil engineering department. And this is a real great pleasure and privilege for me to be here and present my work to you. What is our goal? Our goal is using this fascinating technology, which this speaking series is all about, in our curriculum, which that can enhance our student experiential education from first through the fourth year of their journey. Why is that? Because we have a diverse learner. Our students, they are learning in the different mode, and they have a different sensory for understanding the complex subject. We all know that when it comes to engineering, teaching an engineering concept is quite daunting. In many times, it needs expensive field trip and sophisticated lab. And sometimes this is not really the case for all institutes to do that. And then COVID-19 was kind of, disruptive opportunity. I call it as opportunity because it's kind of to remind everyone you don't have that privilege of going to lab space, to your office every day. That can be a stop for any reason. So having this all in mind, I started to explore the alternative through the innovative technology like augmented reality and virtual reality, which we are going to see today together. But before going to show you some of the activity we develop, I am going to just do a quick definition, which is going to helpful why I have different mode of delivery. Augmented reality is a stand for like we call it AR, and people they know when you are referring AR, it enhances the physical world by using technologies such as digital visual element, audio, or any other sensory which that can make a user experience more augmented or more meaningful. This can be through a smartphone, your tablet, or sometimes AR glasses. And I put here three examples, which one of the great examples is a Pokemon Go, which you are connecting to the Pokemon, like looking in front to you, in front of you on the street, and it's ready to be catch. In more advanced one, when you want to have that responsive interaction with that VR environment and the physical environment, the next topic which comes is a mixed reality. Mixed reality enables users to interact with responsive virtual element, which is kind of connected to real environment through a dedicated headset, recognize its environment and enable the interaction between digital content and the real world. The example could be quite like extensive. I have some example which personally I'm passionate about in the civil engineering and like especially in the digital transformation of the construction area, which you can see how we can connect the design to the real world or the physical asset, and then decide informally what to do next. And then the concept of virtual reality or VR. VR is a technology which you are completely in the immersed and unique environment. It's totally virtual. It could be fiction, and using visual effect and immersive and interactive wearable hardware, such as Oculus Quest headset or Apple Vision Pro, which is gonna come. You are gonna interact with the virtual world. And each of them, they have their own pro and cons. But when it comes to extended reality, it's really the overarching spectrum of all this technology. It's kind of the connecting physical world to the virtual world, interacting with the virtual world, and at the same time you can interact the physical world and see the consequences in the virtual world, and all this considered as extended reality or XR. So when it's come to this, to selecting which technology is useful, it's really depend the use cases. Here I gave you an example, a little bit more detail. When it comes to extended reality, people, they can be in the room, and they can be in the virtual room, and they can interact on some like environment with each other, and be totally like in the immersive way of the discussing about the subject. So what we are doing in the Geospatial Visual Analytic Lab, which I founded, is we have like, that's a kind of, a snapshot of what I'm doing. I'm involved with the development of digital twin when I'm integrating different type of data. I do data analytics for the smart building infrastructure. But what is really missing in all of this when it's come to the data analytic and the digital twin is having an immersive environment which can be used as a visualization tool or front end. So that's why augmented reality and virtual reality became kind of my my second direction of the research when it's come to my technical life. And then when I saw how this can be helpful for technical world and especially in the architecture, engineering, and construction industry, they started using intensively. And I came to myself like, why not we are using it in education, which our students, they really need to have this. So from now on, I'm gonna give you a little bit the story of what we developed inside and how we adopt them. We have a kind of combination of the AR, VR, and then game. Why is that? Because study shows not everyone can use VR headset for the long period of the time. They can have a nauseous, they can have a problem or a headache, and they can be totally distracted. In contrast, some people, they really enjoy being in kind of virtual environment and being engaged. So why is that? It's really depend on cognition and how our brain works. I'm not going to that cognition science part, but I want to show you different application we develop, and you may say why you replicate this, because I really want to offer a different opportunity to our student to be able to learn and to experience. AR is physical, like it's a kind of, you are in the physical world. So meaning that AR technology can be kind of add-on to our lab space, meaning that you should go to your lab space. So when it's come to the remote learning or the period of the pandemic, that access to lab space sometimes is limited. we are not for everyone. Some people, they have a problem. So that's why we investigated and we invested on the kind of the web browser type of the virtual reality, which we referred as a virtual sandbox. So without further ado, I'm going to walk you through some of the activity. First of our journey started with the augmented reality sandbox. This sandbox is being developed first time by US Davis, which they were using this to teach watershed concept to students. We adopted this at Lesson. We built it our own. And what is going on is user, they can see the topographic map projected on the sand. And that's all happening through the depth sensor, which should be in the certain configuration. And I'm going to show you in the video here. So like it's like a basic physical sandbox. So when you're morphing sand in the real time, the topography change, and there are certain like a functionality. If you do your hand like this, that can mimic for generating the water like a rainfall, and you can see how water flows. It's really immersive. I see this. I saw this first time in the science center, and I saw my daughter was playing on and on, and she didn't want to come home, and she was 4 years old, and a few years ago you go back. So I realized that like this is something you can connect people from age of 4 to age of 80. So that's why I got you to this technology, and I started to think of how I can use in my classroom. The way I use it in my classroom was I was teaching a first-year engineering class, which we were teaching a student Earth environment. In this class, since the student, they need to understand the whole system of the Earth, it's sometimes they don't have really passion for us. So like they want to be mechanical engineer, why they should know about our system. So that was like a quite comment I receive a lot. So that's why I started to think, okay, so this is a heavy theory course, how I can turn it a little bit more immersive and more like exciting for the student. By adapting this to my first year class, I asked a student to design a coastal city. Why that? Because I was teaching them about the water flows, watershed, infiltration of the water, like all this concept, which even kind of sometime in the graduate level is daunting. A student, they needed to sketch it, and then I provide them a series of the artifact to develop their desired city on them using the AR sandbox, which you can see one of the example here. And then we show them how their city can be impacted if we have a heavy rain. And that was really fascinating for a student. It was a kind of aha moment. Oh, water is like penetrating that way. I mean, it's some exaggeration here, but they were really engaged with the content without like forced to read the heavy textbook, and that was really goal of the doing this. And even like we show them if you have a high tide or like you have a tsunami, how your infrastructure can be impacted. And we asked them reflective question like, what happened when the high tide happened? So some of the students, they commented like, oh, my bridge was all covered all by water. So that was quite fascinating to see. Even in the first year class, students, they are able to come up with like how they can make more resilient bridge design to encounter such a disaster if that happened on their city. So this happened in the 1,000 level. And then we say, okay, if that's can be effective in the 1,000 level course, so why not just scaling up in putting in the entire curriculum? I grouped with my civil engineering colleague, which they are teaching the geoscience type of the course. But what we realized that there was a limitation on the sandbox. We could not perform complex geological geotechnical modeling. We could not measure the distance for the certain aspect, or having a digital copy of our constructed terrain. And another thing was, when we ask a student to build their city, everything as a built environment, like an artifact we gave them, is considered as a sand and interpreted as a sand rather than built environment structure. So to overcome this, we developed a series of the algorithm, like an object detection algorithm, where every artifact can be recognized on some like a city furniture or some urban like a built environment features, and all this being happen through like in-house coding. And then we add this to our like a built sandbox. By having this, we were really able to do more, because we were able to kind of recognize what are the built environment is and what are the terrain, like distinguish between these two. And the other thing was we built a functionality which they could have a copy of their built terrain and bring it later on for the more sophisticated analysis. But as I mentioned, this is all in the lab. Students, they need to go to the lab. So when pandemic started, we were in the middle of developing this project. That brings us to think of how we can make some adjustment on that. That idea of the virtual sandbox came in mind, so we kind of replicate what AR Sandbox was offering us on the Unity game engine, which a student, they could easily visualize a complex surface terrain model, terrain analysis, and like doing the terrain analysis, and then adding some functionality which was not available before. So I'm gonna just go through the video because it's gonna be much easier to do it. So this is our virtual sandbox, which like as a user, when you are landing on the page, you create your own account, and then you can select the terrain. For now, we have 2 terrain be added. Like one is that, another one I'm going to show you is a York University campus. And you can do a series of the functionality. One of the activity which we developed was a 3-point problem for, and this is one of the lab which being done in the geological structure course, where you put the 3-point around in the point of the interest, and then you can see what is the like a planar surface between these 3 points. And from geological perspective, this planar surface is having a cross section with different Earth's composition. Again, so that was something which was very helpful for a student doing remotely their work. And another functionality we added was the water simulation. You can dump water from the certain area, and you can see how water flows and infiltrate it through the surface. And the good thing about this virtual sandbox was like you could go back and forth between the different mode of the visualization, top view or third person view, or even first person view, which that's coming. We add the functionality of the writing that's being used for the watershed delineation, and like many things more. So here, for example, is the first person view, which you can do the virtual tour. I am going to another thing which we developed. This is a York University campus. Basically, we embedded all of the functionality which we had in our virtual sandbox, but we had like an additional goal here. We want to show if we have a heavy rain and then how the that like urban surface is encountering with a heavy rain and how water is being infiltrated, and which you can and like we kind of generate the water. I hear in this model you cannot see the cloud, even we have the cloud formation, so you can bring your cloud and then you can generate the water, and you can decide how much water you want to you want to have as a rainfall accumulation. And it's a kind of interesting and immersive way which all of the hydrology type of the concept can be discussed through this tool. The same principle, you can switch between the different mode of view, like a top view or third person view and the first person view. For the first person view, our water simulation is it's very rough for now, but we are working on to have a better way of the visualization, because the way we are treating the water is as like a particle, so which in reality like it's kind of considered as a continuous particle. So that's a kind of the technical aspect we are working on, how we can overcome on this. That was something which we kind of replicate our AR sandbox, but like through this whole activity, we are busy with developing other game and other virtual game as well. One of the game which I developed at the very early stage of the sandbox pandemic was a topographic surveying game, which again it's first in its kind. By that time, we didn't have any game teaching surveying. The reason was I was teaching surveying to a civil engineering student, and pandemic started, and this course is a heavy field course, and basically we are staying on the field for 2 weeks, but pandemic it was just interrupted this. So I built this game instead of like going on the field and that being received by students very well. I did a different test of knowledge, and students, they were really gaining the skill they needed. So, and for those of you, if you know how to do surveying, it's like this is an instructional design, so you basically follow exactly the principle which you need to do on the ground. Another application we developed, I really want to partner with multiple discipline, and showing our school we are capable of the offering this technology in many other disciplines rather than only in geomatic or civil engineering. So this is our virtual space project, which is kind of new. We finished it this summer. The idea is giving a student and easily interact with the solar system. It's somehow like crashing the solar system, and everything is realistic physics, and like showing them the astrophysical phenomena. So what we can do through the system, we can edit the time scale, we can adjust the mass of the object or planet in this case, and we can spawn new object with any mass, which that's quite funny. And here is just like a snapshot of what we have and like what we develop. And I'm going to go a little bit further because I really want to show you how you can mess up with the solar system. And this is being targeted to showcase it to K2I student first, and then bringing to first year university, so for more advanced function. Again, this is just a game, and we really want to make people interested in the quite complex physics-based subject. But what about the virtual reality sandbox? So as I mentioned, like we really want to cover everything, which all technology available. We did some try with the virtual reality sandbox. We are using we are using MetaQuest 2 for our development. We developed a series of the application. The first one, the most easy one, was just the virtual tour. We provided two scenes. One is a Swiss National Park, and the second one is the Grand Canyon, which both of them, they're quite interesting natural feature for being studied by many disciplines. In order to showing the capability of this type of system, we develop a series of the electrical or like electronic type of the lab, which that lab is being used for the first year student in the engineering. So we replicate this in the VR environment. The reason is we really want to give opportunity to students to practice over and over without being interrupted, without being intimidated. Sometimes like this device, maybe you consider this like even like it's not that dangerous device. It's just like a basic thing, but for some people could be very daunting to use it, and they can be intimidated in the lab space because we have a limited time for each student. So this, if a student they have access to the VR headset, they can use it and over. Another activity which like a little bit more sophisticated in electronic, we added the DC motor, which again, the student, they can follow the schematic and just do over until they get it, what is going on. And the last one I want to show you is our drone lab, which I'm kind of the proud of it, and we developed it over the summer. And why is that? Because a drone is being used intensively in many industry for surveying purpose, for logistic, like for the delivery purpose, you just name it. Having the capability of understanding how the drone system works, it's really, it's going to be kind of essential for our engineering student. So in this lab, we are teaching the different component of the drone, which somehow they can assemble the drone. And then they can, it's kind of the arena. They can go in a different part of the virtual lab, seeing the mechanic of the drone and understanding the coordinate system. And sometimes it's not that easy to visualize it. And then once they have that idea of the how drone being assembled, they can go to arena and to fly the drone. Here, this is my student who is flying the drone. He's not a good pilot, and he's gonna be trained in the future. But what is really interesting here, this is all correct physically, like if drone crash, like it's really understand the obstacle and everything. And then we have additional function, which once you feel as a student you're comfortable in the flying the drone, you can go to city space. This is the 3D model of the city of the Paris, which you can go for cruising, or you can go for doing a little bit more advanced activity, like doing the surveying, which you can have a control of what you are seeing, as like what you are seeing, or meaning that what drone can see, and all this can be captured as a drone survey type of the activity. That's basically all application we develop, and I hope that could give you a glimpse of what we are doing at Lassonde. As a final remark, we provide this technology for giving opportunity to the student to learn over and over without being interrupted or intimidated. We really want to create an accessible and approachable and inclusive environment for our student to learn. And this immersive experience in the different type of the technology is kind of the helping a student to see the consequence of the decision making design or decision making in, like, you know, in fixing something even. For now, over 200 students are using our virtual game. Over 1,000 students use my surveying game. And I'm working with a 30 faculty member, which we want to enhance our VR sandbox. One voice we all hear from everyone, this is cool. This technology really resonates with people with all age. So that's why we're not going to stop and we are going to continue. But one thing is really missing here is engaging accessibility and inclusivity and learning analytic of this technology, which we started to do and started a study on that. We don't have that much result, but we really want to do an experiment and engaging that learning opportunity for our student. I'm going to stop here. That's going to give us to discuss and take some question from you.
Okay, so thank you very much, Dr. Jadidi. So it was very nice information. So one question is that I have is, I know that you are also teaching the courses for the undergrad or the grad. So my question is, may I ask whether you also apply the VR or AR techniques as a part of your courses and give, for example, some portion of the course markings towards this VR or XR applications?
Yes, definitely. Like we kind of consider as a teaching tool. So some of the like EE experiential activity can be done through that AR or VR, and then we allocate the assessment for that. For example, in my Earth Environment course, a student, they were doing this exercise and they needed to submit a video of themselves explaining a series of explaining the prompt question I provide them in advance, kind of the reflection on their learning. So, and that was one of their assignment they needed to submit, and just one example. To your question, yes, I consider as a part of the assessment. And that's why that gives a kind of the opportunity to a student to be serious about that, rather than just like, we want a student enjoy and enhance their learning. What we find that when you have this kind of the joy with the learning, they have more attention to the content without knowing that they are really encountering the heavy content. So yes, we consider that, and this is the whole goal. We want to work across the lesson to make this technology kind of consistently being used from year 1 to year 4, or our graduate level courses.
Okay, so thank you very much. So one question is from the participant is, how can we learn more? I mean, if you would suggest some resources to learn about AR and VR, and also congratulations, I like the presentation, Dr. Mojgan.
Thank you. About the technology itself, many of the students they are working with me, they are not developer by training. They started to learn through doing research with me. We are using Unity. Unity has a great resources for a self-learning, and they have the whole education department. And then I always encourage my students to take courses outside of, like, you know, the course, for example, LinkedIn Learning, which all of the university students with the York University passport, they have a free access to that, and they have a really good courses which you can understand the theory of the design, game design, the theory of the VR design, because it's not just all about building the technology. The technology sometimes is there. We need to understand how we can use it. For me, it took me quite time to understand how I can use it, and I was privileged because of my background in dramatic engineering. I have already used many of them. I was using Unity front end for my like a 3D modeling. So but if you don't have that kind of, you know, multidisciplinary skill set, I'm just suggesting you go to Unity website. There are other platforms like Unreal Engine, which is open source. Unity is could be free for a student for the research purpose as well, and they have a quite good documentation. This day, we don't need to have, I mean, I'm at university professor, but to be honest, as a like active learner, you don't need to go to university or like taking course to learn. You need to be really proactive. If I tell you you can teach yourself on YouTube, I'm not wrong. So, but I don't want to advocate for that, but I'm just telling you, just go out there, whatever exists. There is no one single course can cover everything. And from use cases to use cases, that could be varied.
Yeah, okay, so thank you very much. I also agree with you, Dr. Jadidi, regarding the YouTube. It's a different topic that we can have a different session for that, but yeah, basically you can learn everything from YouTube or open sources. So I really enjoyed the presentation. So let me know if you have more questions so that in the meantime I can ask another question, because I know when in the university you are bringing a new concept, kind of you are changing the two-dimensional books to the 3D, right? And it's very difficult. May I ask you share some of the challenges that you have faced in your courses or during this process with the students in terms of conveying or transferring this knowledge to them?
This is a very good question. It's really touching in multiple things. Like the whole idea of using that immersive technology is like turning that heavy textbook to the images to something tangible, which you can sense it, you can feel it in the 3D environment, whether this is the virtual or the physical, but like should happen. Like there, for me, the most challenge was like understand that transformation. So not by having the lab content or the lab instruction, you can just turn it to something as a game. For example, for my surveying game, I'm teaching surveying for 7 years now, and I was kind of aware of up and down of the all instruction. So when it's come to design of that, I needed to be kind of a script writer. Like, yeah, you same way you are doing in a movie. I really need to think like very small detail. If student they do this, then what action we can give them as a hint. And that multidimensionality in thinking, it takes time. It really takes a head space to spend and to understand. So when it's come to subject, I am expert on it. It's not that difficult for me to do it. I mean, I spend time, I have my own moment, I'm doing it, that script writing. But when it comes to the expertise with my partner, like my partner helping, like bringing them to that pace of the like, you need to sit and do that script. It's not a paper writing, it's the script writing. And that's the most difficult part, because once I have this script ready, the rest is the development part. It's just not challenge. I mean, it has its own challenges, but it's not that difficult. Another challenge which I had, and I still have, is data. So we are digitalizing our learning space. Sometimes that's not just possible. And sometimes you really need to, for example, for the drone activity, all of these being built in Blender. So we have all model now, but it took us like few months, like full-time RA working on that to build all of this. So if we have a repository which we can go and like a same concept of an asset at Unity, you can go and grab that, and that would be great. Which I raised this issue in the VR working group I'm working with the Canadian Association of Engineering Education. I told them, like, why not we generate we create a repository on GitHub and just share our asset, and then like instead of me to like reproducing same thing, like I can use yours and you can use mine, or we can divide the task. So these two, I think, that are the most challenging part, which making the development and production slow.
Yeah, that's I totally agree with you. And for just for more information for our participant, Blender that Dr. Mojgan mentioned is a 3D modeling software, and Unity, she also said, is a game engine. So when we want to develop, for example, an applications, like great application that Dr. Mojgan showed, we need to create the assets in the 3D modeling software like Blender, and then importing those things in the Unity, and then make that game. And it's a lot of work. I'm not a game developer, but I'm saying in a simpler words for our audiences. So yeah, this is very great. I am very grateful of you. So I am just seeing that if there is no other questions. I have many questions, but I'm just seeking whether our audiences also have other questions. So that, yeah, so one more question is, this is very common questions in this area, which I'm asking from different speakers, and we are receiving answer from different perspectives, different background. So in terms of the simulation sickness, so when we wear this Oculus headset, then after 10 minutes, 15 minutes, we are experiencing dizziness or headache, right? So what's your input, or what's your feedback from the students, or the challenges you faced, and what are the maybe recommendations for this part, so that the students can relieve these type of things, or even from a developer perspective?
Yeah, that's another good question. Thank you for bringing this up. As I mentioned, the reason I'm really looking for the different mode of the technology, AR, VR, and the virtual web browser type is really this. VR headset is not for everyone. We like it's being suggested, even like in normal people having no trouble of the having a VR headset on their head. more than 20 minutes is more than enough. The reason is like how our brain is like absorbing the information is faster than how VR is giving us the information. So that's like that lag between our brain, a processing system, and the VR processing system is creating all of this nauseous and dizziness and ahead like later on the headache you can have. So that's for this reason I try to replicate what we have in our VR environment in the virtual environment, like a virtual web browser type of the environment, which the user, they are not putting the VR headset and having like that sensory of or like a privilege of the doing things with the VR, but being on the screen and then like interacting with the screen. So that's really the way I am dealing with like technology is going to be improved, and my hope is they're going to fix this. I really want to try that Apple Vision Pro, because that many bloggers are saying like this is less like apparent in the Apple Vision Pro compared to others. So we don't want to like do advertise, but just I'm really seeking for that technology being improved, which we are not going to have this. From a student perspective, yeah, some of them, they really like it. They don't mind, but I don't allow them to put for more than 20 minutes because I know this is like a borderline. But some of them, they cannot even use it. Like in the moment they put the headset, they say, oh no, this is not for me. So that's not inclusive if we are just having in one format. So that's why like that virtual game, or we call it as a virtual game sandbox, which like a VG sandbox, which kind of giving the same opportunity to our student to interact. Definitely like in terms of the sensing, it's gonna a little bit less, but that's the limit we have.
Okay, so that's great. So I think I'm just checking that there is no questions. So I can formally declare the end of this speaker session, but afterward I can spend, would you mind if I spend 5 minutes more with you after this session to talk just about some of the developments that we also did on our part? Maybe we can collaborate on this.
Absolutely. Looking forward to that.
Yeah, so okay, then I guess, yeah, so someone asking, will you receive the record? Yes. So after the session, we will also share the video in the CFAL channel. So there is a YouTube channel that if you just search CFAL York, then you would see the videos of the previous sessions and this session. So okay, yeah. So with that being said, I can declare the end of this session, and thank you very much everyone for participating in this session. I wish the best for all of you. So I just stop recording now, and then I keep continue for 5 or more minutes with Dr. Jadidi. If anyone wants to stay, then feel free to stay, because it's just for showing some other works. So, okay.